F-CUBED is a European Horizon 2020 funded project tasked with converting the three very different biogenic residues of paper sludge, olive pomace, and orange peels into intermediate bioenergy carriers via hydrothermal treatment and dewatering, with the added task of uncovering the potential to produce biogas and extract nutrients and oils. And we're now in the final month of the project, so we're here today to showcase the project's research and results. We will also hear from three other EU-funded projects who are conducting research into valorizing waste streams from the olive sector. So, without further ado, let's begin. The first session will provide an overview of the project, its core technology, the tool wash reactor, and the testing conducted from lab to pilot scale of the hydrothermal treatment. The first presentation is entitled F-CUBED, Upgrading of Wet Bio-Residues into Intermediate Bioenergy Carriers, and will be presented by F-CUBED Project Coordinator, Dr. Heather Wray. Heather obtained a PhD in Environmental Engineering at the University of Toronto and is a scientist at TNO, where she focuses on upgrading biomass waste to produce energy and materials and screening life cycle assessments to evaluate early stage processes and technologies for biomass upgrading. So, Heather, please.
I use this. Okay, yeah, so welcome everybody and to everyone online. Thanks for being here. It's really exciting to be at the end of the project and to share all the good work that we've done. It's really exciting. And to be in Florence as well. So I'm just here to give a very brief overview of the project, what our objectives are, how the project is structured, and then throughout the rest of the day you'll hear from our project partners with more on the results of what we achieved. So F-CUBED, as Mike was saying, it really is structured around hydrothermally converting these low-quality, wet, biogenic residue streams into intermediate bioenergy carriers, so pellets, but also biogas. And the goal here really is, so we're in the middle of this energy transition, energy and materials transition, and we need to transition away from fossil fuels to more renewable sources of carbon and energy. So in this energy transition and in the future, a lot of our electricity will be supplied by solar and wind. In the Netherlands alone, it's projected that 70% of our electricity will be supplied by wind. Well, it's a very windy country, but that's great. But of course, biomass is going to also have an important role in this transition. And that can be, for example, for hard to electrify sectors, or for maybe some like local value chains or use cases, or for heat. So it's also really important to also look at sustainable biomass, and one of the most biggest sources of sustainable biomass is waste streams. So how can we use these waste streams? And we like a challenge, so we go for the really wet, difficult, hard to process, nasty, stinky types of residue streams. And the idea there with these bioenergy carriers is it can help balance these fluctuations in the future power grid that will be dominated by wind and solar. So that's the idea behind it. So as I said, we're focusing on these wet biogenic streams. There's a lot of waste streams. And the idea behind F-CUBED is to really focus on streams that have a high potential for energy generation. And so that means biological sludges, so wastewater sludges or other types of sludges, including paper sludge, is also from a wastewater treatment plant, and also lignocellulosic residues. So that's where some of our residue streams come from as well. But in total, these have a huge, huge potential for energy generation, even though they're very wet and difficult. If we can upgrade them, we can get a lot of energy and maybe some other nice things from them as well. So the main objective of F-CUBED is we really want to validate the conversion of these wet residues through our process into intermediate bioenergy carriers. and that's at TRL, Technology Readiness Level 5. And that also means that we demonstrate our process at pilot scale in a relevant industrial setting. So there's different objectives that are technological, sustainability oriented, and also economic. And this isn't all of them, there are more. But the main ones, and ones that you'll hear about today as well. So first, going from lab scale to pilot scale, if you've ever done any pilot testing, it's quite different and it's quite challenging, but it's really necessary if we ever want to scale up, commercialize, industrialize these types of processes. So we really wanted to prove at pilot scale our process, and not just for a day or two, but really long duration testing. So several weeks, continuous pilot scale operation of our process on site in the relevant environment. So that means at the industry where the residue streams are generated. We have 3 residues, as Mike alluded to, and you'll hear a lot about today. So one is paper sludge, the second is olive pomace, and the third is fruit and vegetable waste, which is orange peels in our project. We upgrade the solids into these intermediate energy carriers, and we look at the quality of those pellets that we produce, and look at, what's the quality of these pellets compared to, say, a premium woody pellet, for example. We also look at recovery of value-added products, namely nutrients. And then ultimately, we want to prove that our process is better than current disposal practices or reference cases in terms of greenhouse gas emission savings, but also in terms of the techno-economic feasibility. So we want to show, if possible, that our process is more affordable. So this is the consortium. There's 14 partners. And you'll hear from many of them today, and I'm not going to go into all the details, but we have a really nice group of partners from all across Europe, and that includes, of course, the industrial partners where we did the tests, and also partners for the whole process from the residue stream all the way to the production of heat and power, fertilizer, biogas, and the pellets as the products. There were 8 work packages in the project, and I'll just go through them I'll briefly, but the bulk of the work, again, was this on-site testing. So work package 1, this is where we characterize the feedstocks, and also we want to optimize and de-risk tor wash. So this is really important when you're going to pilot scale. So again, we have our 3 feedstocks here on the left. This is the overall process. We do tor wash, first at lab scale, then at pilot scale, and we de-risk it at pilot as well before we take it to industry. Then also at pilot scale, we have mechanical dewatering with the partner Limburg filter. So that separates the solids from the liquids. The solid cakes are then pelletized, and that goes to combustion testing and quality testing. And the liquid fraction is digested to produce biogas. And we also look at nutrient recovery as well from the liquids and the solids. So this is the overall process, and you'll hear more about this as the day goes on today. So in the first part of the project, we really wanted to optimize our process. So first you do screening tests in the lab, and you'll hear more about this, and then larger tests, and then some tests at pilot scale. And this is really important because, as I said, piloting is really difficult. There's always different challenges from doing it in a small batch scale in a lab to continuous. And that's also one of the really important things about this project. Not many people do pilot testing because it's hard, but it's really necessary to make that leap to industrial scale. We can optimize a lot of different things, but our target was really dewaterability of our residue streams. So really being able to separate well the solids and the liquids. The next 3 work packages were really about this on-site testing. So we take our pilot equipment, they're all in shipping containers, on a truck, and we go to the industrial sites and we do the long duration testing. We dewater it on site, and then we bring the solids back and do the pelleting, and then they go to another partner for biogas testing, the liquids and the solids go to another partner for combustion testing. So we take the pilots all over Europe. which was really fun. So first we were in Sweden to process the paper sludge at Smurfit Kappa, then an olive mill in the south of Italy, and then to Spain for the orange peel processing, and then back to the Netherlands where it sits now. So it's made some kilometers over the last few years. So just briefly on the feedstocks. The first is paper sludge. There's different types of paper sludge you'll hear about today. There's biological sludge. This is from biological or aerobic treatment in the wastewater plant. This is really the problematic waste stream. This is the one that's hard for them to dewater. And so they use fiber sludge, which is a fibrous sludge that's a byproduct of paper making, which is valuable. That's also important later in the project. They use that as a dewatering aid to help dewater it. So that's what the mixed sludge is. It's a mixture of the biological and the fiber sludge. And for F-cubed, as you'll see, we really focus on this biological sludge fraction. So you'll hear more about the pilot testing on site from Dawa, but just to give you a sense of what it looks like when we have our Tor wash pilot equipment in 2 containers and then the membrane filter press on site, and that's the aeration tank behind the Tor wash pilot plant at Smurfit Kappa. So we're really right at the location of the wastewater treatment plant doing the work directly. This is what it was like in Italy at the olive mill. We had set up behind there, and we got the olive pomace directly after the first pressing of the olives, and we could process it again directly on site. And the orange peels as well. So at Della Fruit, they pressed the oranges to extract the juice and the pulp, and then the peels were ground up with some of their equipment and diluted, and then that's the slurry that we processed in our Tor wash reactor. And this is a nice picture of what it looks like in a different location. So you saw Sweden, and this is in Spain. So work package 5, so after, of course, we have all this data from the pilot tests and the lab tests, then we do some modeling, we do a value chain assessment type of work. So this is where we look at the technological, economic, sustainability, performance of our proposed process and what we discovered in our testing, and compare it to reference cases, again, for all 3 of these residue streams. And so to do that, and you'll hear about some of these models today, we use 4 different models. So there's process models, also techno-economic evaluations, value chain assessments, and life cycle assessment, environmental life cycle assessment, social life cycle assessment. And you'll hear about these models today as well. Oh, I got ahead of myself. I couldn't go back. All right. Well, you already saw these nice pictures. So work package 5. And then work package 6 is about dissemination and communication. Well, that's one of the activities that we're doing here today, is sharing our results. But of course, this is really important. We really, like today, we really want to share what we've done with stakeholders and with the general public and with the scientific community. That's really important. The only thing I have to say here is you can check our website or our LinkedIn page or YouTube page to find all of our publications, all of our deliverables, all of our reports. There's some really nice project videos, interviews, and content and information about all the presentations we've given as well. And of course, at the end of the project, there's a lot of stuff happening, a lot of publications coming out in the next little while. So please, if you're interested in really learning more about what we've done, please go to the website and you can learn a lot more there. Or feel free to contact me or anyone else in the project. So that's it. There's my email there. I really hope you enjoy the presentations today. They'll all be recorded. You can also see them online after. Again, go to the websites. And I hope everyone has a nice day, and thanks for being here.